Greetings everyone, my name is Donghyun, a computer engineering student at Konkuk University. Today, I'm really excited to talk about one of my favorite AWS services, Amazon EKS, the Elastic Kubernetes service. But to truly understand why EKS is so powerful, we first need to understand a very common problem that every developer faces. You build an application and it works perfectly on your machine, but when you try to deploy it somewhere else, everything breaks. This is usually because of differences in the operating systems and dependency or software versions. The solution to this problem is the container. Think of a container as a perfect meal kit for your application. It packages your code and all of these dependencies, everything it needs to run, into one neat tidy box. With containers, your application will run the exact same way, no matter where you send it. So, containers are a great solution. But what happens when your application becomes successful and you need to run hundreds or even thousands of these container boxes? How do you manage all of them? How do you make sure that they can talk to each other? This is a huge challenge. You need an orchestrator. To make this easier to understand, let's think of it like a restaurant. In Kubernetes, a node is like the kitchen itself. It's the server with the CPU and memory. The cooks who work inside the kitchen are called pods. A pod is the smallest unit and it's what actually runs your container, your meal kit. And Kubernetes is an amazing restaurant manager that provides powerful benefits to make sure our restaurant runs perfectly. First, self-healing. If a cook suddenly gets sick and can't work, Kubernetes instantly hires a new healthy cook to take their place, such as a pod. You don't have to do anything. Second, automating rollbacks. Let's say you introduce a new dish, new pod, but the recipe is wrong and customers are complaining. Kubernetes instantly pull the bad dish, bad version of the pod, and go back to the old trust version of the recipe. Third, auto scaling. When the dinner rush hits and you have hundreds of customers, Kubernetes automatically hires more cooks to handle the load. When it gets quiet again, it sends them home to save money, reducing the pods. And finally, load balancing. Kubernetes acts like a smart host on the front door. It takes all incoming customers' orders and distributes them even among all the available cooks. So no single cook gets overwhelmed. Now, this diagram looks very complex, but the idea is pretty simple. The Kubernetes cluster is divided into two parts. The control plane is the brain of the operation. It makes all the important decisions like where to place a new pod. The worker knows all the muscles. They do actual work of running your applications. In my research lab at Konkuk University, I build and manage Kubernetes clusters just like this one on premise. We are responsible for managing the brain, the control plane ourselves. And trust me, making sure this brain is always available, secure, and up to date is a huge complex job. It requires a lot of operational effort. And that is why Amazon EKS is such a game-challenging service. EKS solves the difficult problem just like I described. With EKS, AWS tells us, don't worry about managing the complex brain. We will manage our control plane for you with all our expertise in security and reliability. This means we can get the power of the Kubernetes without the headache of managing its most complex part. As the slide says, it allows you to focus on your application, not the infrastructure. We can just drive. This power to simplify and empower developers is why I'm so passionate about AWS. And it's exactly this passion and practical knowledge that I want to share by establishing the first AWS Cloud Club in my university. Thank you for your time.